All right, math friends, it's Bass Action back in action here. In our last video, what we looked at were properties of a parallelogram, and we found that there were 5 properties of a parallelogram that existed in no matter what parallelogram you were given. In this video, what we're going to look at is how we can show that something is a parallelogram, because similar to what we did with our congruent triangles, if we knew some triangles were congruent, then we would know that all the corresponding parts were congruent. So similar idea here, if we know that something is a parallelogram, then we would know that all those other properties would exist. So we want to look at some various ways that we can identify whether or not something is a parallelogram, and then what we will do in class is we will actually start to try to prove this, but we're not going to do our 2-column proofs. We're going to do coordinate geometry proofs on these that I think you'll find easier than what we did last semester. So let's take a look. The very first one that we can do here is using our definition of a parallelogram. So remembering that our definition of a parallelogram is both pairs of opposite sides are parallel, that's exactly what we could show. We could show that both pairs of our opposite sides are parallel. Now, visually, if we're going to mark this in our picture, what of course that would mean is that these two sides would be parallel to each other, and these two sides, you would have to show both. If we're thinking coordinate geometry, we could show that lines are parallel by using our slopes. So what we're looking for are same slopes. And we'll get into some examples, but I just want you to be keeping that in mind, that if we're trying to show that things are parallel, we're looking for same slopes. So opposite sides would have the same slope in both cases. Our next way that we could do this is we could also show that both pairs of opposite sides are congruent. So what should be standing out here is, wait, aren't these the properties of a parallelogram? Yes. The properties of a parallelogram are biconditional statements. We can use them to, they're both properties, and we can use them to prove congruence or identify that they are parallelograms. So both pairs of opposite sides are congruent. So of course we would mark those as congruent, and we would mark these as congruent. Visually, that's the type of notation we're looking for. If we're thinking in terms of a coordinate geometry proof, what we're actually thinking is our distance formula, okay? So we're going to be thinking our distance formula for these. So if the opposite sides had the same distance, both pairs of opposite sides had same distance, then we would have a parallelogram. Our next one that we're going to look at is a way to prove that a quadrilateral is a parallelogram is show that the diagonals bisect each other. So what we did in our picture last time in our foldable is wow, those are terribly unstraight lines, but that's okay. We showed that these were the same midpoint. So in terms of coordinate geometry, we're looking for those to be the same midpoint. Of course, we could also think of it like this, that those two pieces were congruent, but same midpoint is going to be our fastest approach on that property. The next one is show, and this one is unique. This is a different one. Is we're going to show that one pair of opposite sides is both parallel and congruent. So for example, let's say I wanted to work with these sides right here. I could show that those two sides are congruent by using my distance formula, and I could show that they're parallel by using my slope formula. So I would have to do both distance and slope on this, but I would actually be using the same pair of sides both times. It doesn't matter whether I would choose those sides or whether I would choose these sides. What matters is that when I do that distance and slope, that I use the same pair of sides for both computations. So that would take care of that. And then my last one that I could do, but we won't be able to do this with coordinate geometry, we could show that both pairs of our opposite angles are congruent. So if we could somehow identify something that looks like this in our picture, both pairs of opposite sides or opposite angles are congruent, we could also identify it as a parallelogram. But in this case, we won't be able to really use this for coordinate geometry because none of our formulas will work for that in terms of coordinate geometry. All right, so we are going to apply this. I have an example in the next video for us to look at this, and then we will dive into it more deeply in class.